Welcome students. Welcome to talk on civil engineering. Let us discuss how we can derive an expression for a kernel of rectangular section, or we can call in another way like core of rectangular section. So we all know that core is nothing but the section within which you can apply load, so that the section in the section no tensile stresses are generated. Okay, so if you apply the load within that region, so there will be no tensile stresses. Usually in a columns concrete columns, if load is applied with some eccentricity, you will get a combined stresses has a direct stress plus or minus the bending stress. Okay, so the summation of these two usually it will be in compression itself, and the subtraction of these two sometimes may generate the compression stresses, or sometimes it will result into a tensile stresses. So that is sigma minimum. So sigma minimum, that is sigma d minus sigma b. So sometimes it will give a tensile stresses. Okay, so this tensile stress, that is sigma minimum, should be 0 or it should be greater than 0, so that it will become the compressive. So tensile, will say it is tensile when the stress is less than 0. Okay, so that means when sigma minimum is greater than or equal to 0, it will be compressive. If it is less than 0, it will be tensile. So we should make the sigma minimum either equal to 0 or greater than 0. Okay, so that there will be no tensile stress in the section. Okay, now let us try to derive the section within which the load can be placed, so that no tensile stresses are developed. Okay, so we know the sigma minimum should be greater than or equal to 0 in order to avoid these tensile stresses. And what is sigma minimum? Sigma minimum is nothing but the direct stress minus the bending stress, and it should be greater than or equal to 0. Okay, and what is sigma d? It is the direct stress. We can write it as P by A, and bending stress we can write it as moment due to the eccentricity, that is P into E. It is a moment due to eccentric load divided by Z, section modulus. So this PE divided by Z will gives you the bending stress. So it should be greater than or equal to 0. Okay, and further we can write this equation as P by A minus PE, and Z, that is section modulus for a rectangular section, is nothing but BD square by 6. Here B is the width of the section and D is the depth of this rectangular section, right? And so it should be greater than or equal to 0, and we can write this equation as P by A minus PE by 6 times of PE, and BD we can separate this as A into D. So it should be greater than or equal to 0. So simply here this is BD square is there, right? So I have separated this as B into D into D. So B into D is nothing but area, so it will be A into D. Okay, and I can rewrite this equation as, so I can take PA common, P by A as common, so P by A 1 minus 6 times of E divided by D. Okay, right, so it should be greater than or equal to 0. Okay, and here if you see the section modulus, this section modulus is with respect to x axis. So this section modulus is respect to x axis. For rectangular section, you will get two section modulus, that is one with respect to x and one respect to y. So this is with respect to x axis. That is the reason I have written this equation as BD square by 6. Okay, so I have taken P by A common, and if I take this P by A to the side, it will become 0. So simply I can write this equation as 1 minus 6E divided by D should be greater than or equal to 0. So let me take 6e divided by d to that side. So it will become 1 greater than or equal to 6e divided by d. So I will take 6 by 2 to 6 by d to that side. So it will become d divided by 6. So d divided by 6 should be greater than or equal to e. Or in other way, we can write this equation as e should be less than or equal to d by 6. So this is the loading limitation in order to avoid the tensile stresses in the rectangular section. Okay, so if that means if you provide the loading within the d by 6, so here this is the d, right? So this is your d. So within the d by 6, so let it be, this is these points are, this is the d by 6. So if you provide the loading within this d by 6, there will be no tensile stresses in the section. Okay, similarly, if you derive the expression about y axis, so it will be the same, like, so this is about xx, so it will be, if you write about y, so it will be b by 6, that's it. Okay, so b by 6 or something, so it will be the kernel, the core of section will be something like this. Okay, so this is my kernel section. So if you place the load within this region, so there will be no tensile stresses generated. So this is b by 6, or so if this will be d by b by 3. This will be b by 3, right? So that's the reason this is also called as middle third rule. So this is also called as middle third rule. So this is d by 3. This is d by 3. Sorry, d by 3. Okay. So I hope you have understood how we can derive an expression for a rectangular kernel of or core of rectangular section. Thank you all. It is a simple derivation. Thank you.